Okay, so we're outside the microfluidics lab and we've got Myra here who's about to do an experiment. So tell us a bit about the experiment you're going to do.
Hi, so my name is Myra and I'm studying a PhD student here at UNSW Sydney, Australia, and this is the microfluidics lab in which I'm going to test some microfluidic devices that are actually being used for separation of some cells and some very interesting application that actually got, like for some biomedical applications and some microalgae application as well that could be used for some like biofuel production, as well as for the best thing is like it could be used for the cancer detection as well, for the early diagnosis of cancer. And this is a simple device that I'm actually talking about. So it got like one inlet in which you get your cell suspension here, and then from the two outlets you can get your separation done.
Cool. And how big are those channels?
So we get it through like microfabrication using soft lithography. So we actually get some molds, some aluminum molds, and then we cast the PDMS on them, and then we harden it, and then they're ready to use.
Cool. Yeah. Okay, great. We'll go into the lab and have a look at the experiment.
Yeah, sure. I'm just putting in the tubing inside it. Okay, so this is the microscope, the fluorescent microscope that we got in our lab, and it's called the inverted fluorescent microscope. It got a light source at the top, and we got some lenses at the bottom of it. And you can see like our spiral channel is actually attached here, mounted on the surface. And we also got our tubings here, and it's attached to the syringe pump. So we use this pump in order to push through our the liquid particle suspension through it, and then it just swirls inside, and the particles or the cells got separated on the both outlets.
So what's that in the syringe?
Okay, so in the syringe we have filled it up with some particles, with some fluorescent particles. So these particles are actually polystyrene, which are good surrogates of some cells. Like we are going to use it for mimicking the cells, some mammalian cells or some cancer cells. So these have the same density and size as that of the cells. So that's why we are using it. And they are fluorescently labeled so that we can actually view it inside our channel. So as you can see here, so our device is actually like through the microscope we can see our device here. And as you know, like we had two different outlets. So here we got the bifurcation for the two outlets, and right now it's not we don't have any flow through it, so you can see some of the particles standing here, and you can also see I can also show you the different loops of this. So it got about like 8 loops, and it ends as this bifurcation. And you will see that for these loops, the particles will be a bit dispersed. But in the end, it will exit only through one outlet.
Great. And so are these little particles we can see going around here?
Yeah. So right now, as we don't have any flow, so they're just randomly dispersed. So now I'm going to start a syringe pump. I already got my syringe here, and I've set the flow rate as 1 milliliter per minute, and I'll just run it. And now it should take some time to pass through, and then see that something's happening now. So if you look quite closely, so here you can see some of these flashes. These are actually the particles passing through this in the form of like their trajectories.
And now they're moving quite fast. So
Yeah.
Yeah.
Yeah. So as you see, like for this outlet, there's nothing going on here. So it's just the fluid. And for here, all the particles are going here.
And is that what we want to happen?
Yeah.
For them all
Yeah.
to-
Yeah. So that's how we get the separation of the cells from the media.
Okay. And so how many cells, do you get all the cells going up to the right?
Up
Or-
to like 95%, I would
Okay.
say.
So
Yeah.
that's pretty good.
Yeah. It works like magic.
Microfluidic magic.
Yeah.